So now we're going to talk about solving with square roots and completing the square. So a few things to remember. First, quadratics happen when we have x squared. And so we just need to remember that this means we're going to have I hate when I do that, two solutions. All right, so some simple questions to start with. And I just added another one, so sorry. Some simple questions to start with. So the goal is to get x by itself. So on this one on the left, x is already kind of isolated. I just need to get rid of this squared. So I'm going to take the square root. And if you remember, this gives me x equals, the square root of 25 is 5, and the negative is an I. But remember what I just said, and I think we've talked about this before, but x squared means I need to have two solutions, and right now 5i is just one solution. So when we take square roots, we tuck a little plus minus sign in the front, which will help us have two solutions, because now we have the positive and the negative version. All right, this next question, you have a few options. We could make this equal 0, like we were doing with factoring, so I'm going to do that real quick. 8x squared minus 32 equals 0. And if we do that, I can now take a GCF out. I can divide by 8, and that will give me x squared minus 4. And hopefully you remember that breaks apart with difference of squares. So this is x plus 2, x minus 2 equals 0. So all of that is actually by factoring. And that gives me two solutions of x equals negative 2 and positive 2. So the alternate option there is instead of, and this is weird, this only works with square roots. If all you have is x squared, you don't necessarily have to make it equal 0. You could treat it like visitors. So let me give you the other option and how we would solve this second question. So for instance, I'm going to try to isolate x squared here by getting rid of my visitors. So to do that, I'm going to add 5 to both sides. That's going to give me 10x squared equals 80. And then I'm going to divide by 10. So x squared equals 8. And now I can do what I had done on that first question. I can take the square root and I can simplify. If I try to simplify the square root of 8, that's 4 and 2, which is 2 square root 2. And some of you are going to make the mistake of leaving this question like that, but you can't do that. You need this to be two answers. So this is really x equals plus or minus 2 square root 2. You need to be comfortable with both of these options in terms of taking square roots and factoring with GCF. Now, that being said, a question like this is most simply solved using square roots. And the reason is because I can isolate this part very easily. So again, I'm going to treat this almost like I'm doing visitors and try to get rid of my extra pieces. So I'm going to add 5 to both sides. That's going to give me 2x plus 3 squared equals 22. And then divide by 2, just like I did with absolute value, equals 11. And now that I have that part isolated, I can get rid of this squared by taking the square root, right? The thing that you need to remember is, so with absolute value, we used to split it apart because there were two options. And I could technically still do that. X plus 3 equals the square root of 11, and x plus 3 equals the negative square root of 11. So for some of you, you're going to actually probably prefer that because it feels more like the other way. But the simpler way to write that, so I'm going to bring this back together. The simpler way to write that is just x plus 3 equals plus or minus the square root of 11. Remember, this plus or minus is happening because when I take this square root, I need two answers. And now all I have left to do to isolate x is to subtract 3 from both sides. So that's going to leave me with x equals, and the reminder I'm going to give you here is think about what it looked like when we wrote quadratic formula. If I have the square root of 11 and a negative 3, and I'm writing that with quadratic formula, the negative 3 would come first, and then the plus or minus square root number would come at the back. Remember, just like that should remind you of the format for quadratic formula. So that is my answer to this problem. And you could maybe just add this note to think visitors if you have parentheses squared. Okay, so before we do our completing the square example, which by the way you have done before, you did it in geometry when you wrote equations of circles, so this should be familiar. I just want to explain to you why this process is what it is, so you have some context. So a perfect square is a number that can be multiplied, like something can be multiplied by itself. So for instance, 4 is a perfect square because 2 times 2 equals 4. X to the 6th is a perfect square because x to the 3rd times x to the 3rd can equal x to the 6th. Likewise, 2x plus 1 is a perfect square because 2x plus 1 times 2x plus 1 equals 2x plus 1 squared. So remember, the whole purpose of this is that it's something times itself. And even if you think about like a physical square, a square is a square because it's the same on both sides, right? Well, square numbers are square numbers because it's the same value multiplied by itself both times. So one thing that I want to show you, if I give you this example, I'm going to give you an easy number. Let's say x plus, let's do 7 squared. So this is a perfect square, and if I write this out as a perfect square, that's x plus 7 times x plus 7. And if I multiply that, I'm going to do some distributive work, right? And I'm actually going to go ahead and skip ahead and show you what that would give you. When you work this all out, you're going to get x squared plus 14x plus 49. So a few things that I want you to see, connections. I want you to see that 7 and 49, 7 and 14. From 14 to 7, that's half. Or if you go the other way, it's double, right? That's the relationship between those two. And then 49 is this value squared. And that is true of any perfect square if you multiply it out. So for instance, if I give you x minus 5 squared, the multiplied version of that is x minus 10 plus 25. Sorry, that's an x. Because again, we've got this same relationship of double, half or double, and squared. Okay? So that's going to come in really important, and I would maybe make a note of this before you look at the next part of the video. All right, so this last problem, you could solve this, and you are welcome to make a note. You could solve this by setting it equal to 0 and using either factoring or quadratic formula. And some of you are going to prefer that. And if I'm being honest, I generally prefer that. If I don't see parentheses squared, that is always my option. Set it equal to 0 and either factor or do quadratic formula. But I want to show you this third method just in case it is helpful for you, because some people really feel like this is an easier option. So what I'm going to do is complete the square. And what that means is I'm going to rewrite this question so that I have parentheses squared so that I can just take the square root. So that's my goal. So to make it look like that, I'm actually going to move the 3 to this other side. And I'm going to end up with x squared minus 8x plus blank equals 12, right? I subtracted 3 from both sides. So my goal is to make this parentheses, sorry, I'm skipping ahead of myself. My goal is to make this parentheses squared. And to do that, I'm going to cut this number in half. So it's going to be x minus 4. And then I'm going to square it to fill in this blank, 16. Now, I just added 16 to the left side, like I literally just wrote that there. So if I do it to the left, I also have to do it to the right side, which is going to now leave me with this problem, x minus 4 squared equals 28. So now I'm set back up to easily take the square root. And in fact, I don't even have any visitors to get rid of. I'm just ready to take the square root of both sides, which is then going to give me x minus 4 equals plus or minus, see, 4 goes into that, so 2 square root 7. And I'm going to add 4 to both sides, which will give me x equals 4 plus or minus 2 square root 7. So the last thing that I want you to note then about completing this square, it is easy when b is even. Obviously, if this middle number is not an even number, when you go to cut it in half, you're going to have a decimal or a fraction, which is going to be more annoying to deal with. It is also easy when a is 1. And it's not that it's impossible, because it is absolutely possible to complete the square if there's a number out here, but obviously if there is a number out there, there's a whole extra set of steps to complete the square. So again, not impossible, but if we're talking about solving quadratics, I don't necessarily know that that is a simpler method than just setting this equal to 0 and trying to factor or do quadratic formula. So that being said, we are going to practice this skill tomorrow. But then moving forward after that, I'm going to give you the option of how you choose to solve it. So make sure you have all these things in your notes and that you're ready for class tomorrow.